do this. So if we multiply both sides here by 10, we can actually get 8,184 divided by 12. And that's the key thing here, is getting rid of the decimals. Because it's just a ratio like this, 8184 over 12, it's the same as 818.4 over 1.2. So we can just multiply each side by 10 and get this. From there, we have to do some long division, like this. So 8184. 12 goes into 81 6 times, and 12 times 6 is 72. So we'll take 81 from 72 and get remainder 9. And then we'll bring this 8 down here. And 12 goes into 98 8 times, and that's 96. And then we'll minus that from that, and it remains 2. And then we'll take the fourth thing of that question, was realizing that we don't want to really do it with decimals, but the ratio is the same. Okay, question 19. The table shows the probabilities that a biased dice will land on 3, 4, 5, and 6. And these are the probabilities here, it looks like. Karim assumes that the probabilities that the dice will land on 1 and 2 are the same. Karim rolls the biased dice 500 times. Assuming Karim is right, work out an estimate for the number of times the dice will land on 2. Okay, so it looks like a lot of information, but this is just a probability question. Now, probability is usually out of 100%. So, out of 100, or in this case, out of 100% is equivalent to 1, because they're using decimals. So these are all percentages as well. So you could say that's 10%, that's 30%, that's 5%, and so on. So it says work out the number of times the dice will land on 2. So we need to work out what this number is here. So first of all, we'll work out what the remaining ratio is. So we do 1, which we know is 100%, and we take away each of these numbers. So minus 0.1, minus 0.3, minus 0.05, be careful with that one, that's 0.05, minus 0.25. If it's easy, you can add them, change them to percentages and just add them up. So it is easier sometimes to say 25 plus 5 is 30, plus 30 is 60, plus 10 is 70. So we do 1 minus 70%, which is actually 0.7. So 1 minus these, 0.7 equals 0.3. So that's the remaining ratio for 1 and 2. And it says that he assumes that 1 and 2 will be the same. So if they're the same for 1 and 2, we'll just divide this by 2. So the ratio for the probability of 2 that will land on 2 is 0.5. So now we just need to work out how many times that will land on 0.5. So we just do 0.15 times 500. Now, it does look quite difficult, but 0.15 is just 15%. And if we find it easier, we can actually find 10% plus 5%. So 10% of 500 is 50. 5% is just half of what we found there. So it's 25. So 15% is 75. So it'd be 75 out of 500. That's the number of times the dice will land on 2. Okay. It says Karim is wrong. The probability that the dice will land on 2 is greater than the probability that the dice will land on 1. How does this information affect your answer to part A? So this is a descriptive question. It's basically asking why this will change. And it's because, how does this information affect your answer to part A? Well, part A, we currently have 75 out of 500, and it says the probability that dice will land on 2 is greater than the probability that dice will land on 1. So dice will land on 1 is also the same as we know, which is 75 out of 100. So if 2 is greater, then the answer to part A here will be greater. So the answer to part A will be greater. There we go. And moving on to question 20. Work out 3 1/2 minus 1 1/6. So this is just, again, it's arithmetic. It's figuring out whether you want to convert these into improper fractions, or you can just do it by making the denominators the same. In this case, I think it's easier for me personally to convert them to improper fractions. So we just do 3 times 2 is 6. So we get 6 over 2 there. That 3 is the same as 6 over 2. But we have half as well. So we add that half back on. So this number is equivalent to 7 over 2. This second number, 1 times 6 is 6. So it's actually just another 6 on top of this. So it's 6 over 6 plus 1 over 6. Because 6 divided by 6 is 1. And that equals 7 over 6. And now we need to just do 7 over 2, which is our improper fraction, minus 7 over 6. The denominators are different, so we can't just take them away from each other yet. We need to make this one equivalent to that. To get from 2 to 6, we times by 3. So if we times 7 by 3 and 2 by 3, we get 21 over 6 minus 7 over 6. And then we can work out that because the denominators are the same, 21 minus 7 is 14 over 6. Now there we have an improper fraction, but the question says to give your answer as a mixed number. So in this case, how many 6's go into 14? Well, 2 6's make 12, so that's 2, and there's a remainder of 2. So it's 2 and 2 sixths. But we can also reduce this fraction here to 2 and 1/3. So the answer is 2 and 1/3. Okay, part B. Another question using whole numbers and fractions. So in this one, I think the easiest way, again, is to convert these to improper fractions first. So we do 5 times 4 is 20. So 20 over 4. We can see that's right because 20 divided by 4 is 5. 20 over 4, and then we add the quarter on. So that's 21 over 4 for this first one. And then for the second one, we have 2 times 3 is 6. So that's 6 over 3, which we know is right because 6 divided by 3 is 2. And we add this third on as well, which equals 7 over 3. And then we want to divide 21 over 4 by 7 over 3. And we can see that here we have a division. And when we divide in a fraction, it's the same as multiplying by its reciprocal. And now the reciprocal is just when we flip these two, the denominator and numerator, in here. So we do 21 over 4 is the same as 3 over 7. So that's just finding the reciprocal of this number. And then we can work that out. We can do 21 times 3. So 20 times 3 is 60, and 1 times 3 is 3. So that's 63. And then this is a 4, not a 6. 4 times 7 is 28. There we go. So always make sure to round down, simplify the fraction if we can. In this case, I can see that these are part of the 7 times table, so 28 can be divided by 7, so can 63. 63 divided by 7 is 9, and 28 divided by 7 is 4, so that is the simplest answer there. 9 over 4. Okay. Question 21. ABDC is a parallelogram. That's important. Looks like it's a shape question about finding the angles. Okay. All angles are measured in degrees. Find an expression in terms of E for the size of angle CAD. Give a reason for each stage you're working. Okay, so let's find out what we're trying to figure out here. So CAD. CAD. Now the angle we're looking at is the middle letter of CAD. So that's this angle here. We're trying to figure out this angle. And what we can notice here, the diagram already has split this into two triangles. Also, we know it's a parallelogram. So these lines and these lines are parallel. Now, we can look at this first triangle here and we can say, well, we've got E here. What's this angle here? And we know that with parallel lines, this is an alternate angle, which means it's exactly the same as this angle. So this is also E. And then remember we said about triangles, this is a triangle, this is a triangle. We know that triangles or angles in triangles add up to 180 degrees. And then we also write down that alternate angles ACD is equal to BAC. This angle is equal to that angle. And now, so we know that this angle here I'll label X. We can figure this out now because we know that angles in a triangle are 180. So we take away 3E plus 4E, plus E, sorry. So 180 degrees minus 3E minus E will give us what this answer is. So we can simplify that further and we can say that 180 minus 4E equals X. That is the answer for that angle there. And it is a bit hard to get your head around sometimes. It's just about using and finding what angles match up and the fact that it's a parallelogram, so all the information's there. These questions can be quite difficult though because it's not an exact number you use in algebra, so just take your time with them and you'll be fine. 180 minus 4E. Okay, question 22. Car travelled 4.96 miles at an average speed of 30.4 miles per hour. Work out an estimate for the time taken by the car. Give your answer in minutes. Okay, so make sure you give the answer in minutes there. So here it says an estimate. So we don't need to work out this times this or this divided by this. Okay, so if we remember our distance, speed times time chart, well, we have the speed here, which is 30.4, and we have the distance, which is 4.96. So we'll round these to a number that we find better. So we'll do 5 divided, distance divided by speed, 4.96, which is 5 divided by 30. That'll make it easier for us. Distance divided by speed equals 1/6, and that'll be in hours, which gives us the time. But remember, the time is miles per hour. So we're actually in hours currently, so it's 1/6 of an hour. So now if we just convert hours to minutes, how many minutes are in an hour? There's 60 minutes in 1 hour. So we need 1/6 of an hour. So to get 1 hour to 1/6, we divide it by 6. So we also divide the minutes by 6. So 60 divided by 6 equals 10 minutes. If you answer in minutes, there we go, 10 minutes. Is your answer to part A an underestimate or an overestimate? Give a reason for your answer. Now, I struggle a bit with these questions sometimes because they're wording questions. And if you look at the question itself, it's not as difficult as it sounds, okay? So we look, is it an underestimate or an overestimate? Okay, well, the actual speed is 30.4 miles per hour and the distance 4.96. Now our car, we changed to 30, so the car's going slower, it's going slower, and it's going a further distance. So our time here is actually an overestimate because the journey will likely be quicker if it's going slightly faster and slightly less journey. So it's an overestimate. And the reason is because the car is going, it's going slower and further in our answer. There we go. Okay, question 23. Here is a pentagon. Okay, so we've got a shape here. We've said it's a pentagon. Again, it's another angle question. Angle A equals angle C, angle B equals 155, angle D is 3 times angle C, angle E is 2 times the size of angle C. Okay, so it looks like everything is in terms of angle C here. And we do have one angle here of 155 degrees. So the first thing we need to figure out is what all these interior angles add up to. Now the interior angles of a shape is 180 times n minus 2, where n is the number of sides. So we have 5 sides in a pentagon, so 180 times 5 minus 2, which is 180 times 3, which equals 540 degrees. So that's the total. We know that one's 155, so we'll take that off. So if we take off this from this, then we take off 40 from this to get 500 minus 115. We take off 100, so we get 400 minus 15. So then we get 385. I think that's right. Yeah. So 385, which is the remaining angles, is equal to C. Angle A is equal to C. Angle D is 3 times angle C, so it's plus 3C. Angle E is 2 times the size of angle C, so it's plus 2C. 385 is equal to 1 plus 3 plus 2, 6C. Okay, so I've done this wrong here because we've actually got the angle C as well itself. So it's actually plus another C, so it's 7C. And we divide that by 7, and we divide 385 by 7. Well, if we look at this, we can say, well, 350 or 35 is divisible by 7 to make 5. So 350 divided by 7 is 50. And that leaves us with 35 left over. So 35 divided by 7 is 5. So 50 plus 5 equals 55 degrees. So each angle is 55 degrees. Oh, we've already got the degree there. There we go. Okay. The graph shows the volume of water, V litres in a tank at t seconds. What does the gradient of the graph represent? The gradient of the graph here represents the rate of the water that's poured. So as the volume of litres goes down, the time goes up. So in this case, it would be that it's how fast the water is being used. So it's how fast the water is being used. Which in this case, you could also say it's the rate at which the water is poured, or the speed of pouring water from the tank, because it's to do with speed, you see. Okay, question 25. I like these questions because there's just one answer, there's no descriptions, so let's go for it. So make W the subject of the formula. So this is an algebra question, as we can see. And all we've got to do is do the same thing to each side of the equal brackets. So y equals 3w minus 10. So if we add 10 to each side, we get y plus 10 equals 3w, because we've added 10 to minus 10 to make 0. And then we just divide each side by 3, because we've got 3w. If we divide 3 by 3, we get 1. So we do y plus 10 over 3 equals w. And that's it. It does look quite complicated at the start, but algebra, once you practice it, it just becomes second nature, and it's all just practice. So w equals y plus 10 over 3. There we go. And finally, question 26, the last question. So looking at this here, this is a quadratic because we can see it's got a square here and one value of x here and then no value of x here. This is a quadratic equation. Now, there's a few ways to work out a quadratic equation. You can use a quadratic formula. However, I prefer in this case to look at it and try and factorize it. So we know there's only two x's, so we do x in one bracket and x in the other. And we look at this number here and we say that something has to multiply together to make this number that also adds together to make this number, the second one. So let's look at what we got. The factors of 15 are 1 and 15, 3 and 5, and that's all of them. So it can only be these two numbers in here. Now we need to look at these factors and say, which of these can add up to minus 2? Well, this will be minus 14 or 14. This will be 2. 3 minus 5 is minus 2, or 5 minus 3 is 2. So it's 3 minus 5. So in that case, we'll put minus 5 in and plus 3. And we'll just check that again. So x times x is x squared. X times minus 5 is minus 5x plus 3x minus 15. 3 times minus 5 is minus 15. So that is correct there. So what does it say? It says solve it. So we need to figure out what x is. So this is equal to 0. So for this to be equal to 0, this x needs to be 5 plus 5. And for this to be equal to 0, this x needs to be minus 3. So x equals 5 or x equals minus 3. Okay, that's everything. So thanks very much for watching and good luck with your revision.